What has always fascinated me is human history. What made humans colonize the entire planet, fly into space, knowing that our ancestors mixed with Neanderthals, some of this genetic contribution plays a biological role. Paleogenetics is then what I have focused on developing over the last 30 years. Techniques to retrieve genetic information from long-dead organisms. These techniques allow us to actually go back in time, to actually see what it was like in the past. By 2010, we're able to arrive at the first draft version of a Neanderthal genome and compare it to the genomes of people that live today. What really shook me was the fact that Neanderthals had actually contributed to the genomes of present-day people that are around today. Modern humans, the direct ancestors of everybody around today, appear first in the fossil record in Africa, then spread out of Africa starting 50 to 60, 70,000 years ago. The first place where they meet other forms outside Africa is presumably in the Middle East. We know there were Neanderthals there. If we then look at these pieces of DNA modern humans picked up, one group are keratins, structural proteins in skin and hair. So some aspect of the skin and hair seems to come from Neanderthals. There is another variant that today confers risk for type 2 diabetes. I would speculate that that's probably some adaptation to survive starvation. And today, when we have even too much nutrition, we actually get diabetes from these variants. Until 40,000 years ago, there were other forms of humans here. All these other forms became extinct, and the result is that we are alone on the planet. But maybe it's a little comfort that 40% of the entire Neanderthal genome actually walks around still today in us.